Hello everyone, this is Aida Golami from Agreement Soft Research Company, and I'm here to teach you how to make your SWAT model and how to build the SWAT model. So in the previous videos, I have taught you how to make your land use map, how to make your dam map, how to prepare your soil map, and how to inform all these maps to your SWAT model and how to prepare them in order to have it ready. So in this video, we're going to put all this information together and use it in order to make the SWAT model. And another thing I want to mention is that in those videos, I have taught completely how to download a SWAT interface for ArcMap. I have taught you what is the like compatible versions for SWAT and ArcGIS, and so if you want, you can go back to the videos and use the information provided there. Now, the first thing you need to do is to go to this section and click New SWAT project. Save current document. I actually say no, but if you want to save that document, if you have valuable information there, it's obvious, you should say yes. Save changes, no. And project directory. Here you want to set your project the directory, like your project folder, and the thing you want to mention is that the name you give to your SWAT model should be, for your SWAT folder, should be very easy and very tidy. You don't want so many like characters and so many numbers and those things. For example, I wrote SWAT video, so I will click on that. And then you want to make a name for that project. I will say SWAT and click OK. So I click on that and push OK, and then it will just make other things based on that directory. Click OK. Project setup is done. Now you have space to inform your inputs and start making your project and making your model. The next thing you should do is to go to watershed delineator and click automatic watershed delineation. So here it wants to open DEM raster. Now I told you how to make your raster map, and now it wants the DEM raster. So I will go through it and load from disk. Okay, and I will go to SS data. Okay, now the next thing is DEM projection. DEM projection, you click on that, and in Z unit you should click on meter and then click OK. And I use this burn in option because I want to burn in my river streams that I have. I have the shapefile. Okay, from disk and streams, river final shapefile, and you add it, and it will burn into your DEM raster. Then you should go through stream definition. Use DEM based because predefined streams and like watershed is needs a lot of accuracy, and actually me myself, I don't know how to do that. I know it should I know you should use Hecras in order to make those files, but I don't know how to do it, so I use them based. Flow direction and accumulation, you click on that and it just does all the calculations. End of them grid processing. Okay, and here it says how many hectares is your area and how many cells do you have in your study area. Then you should go to stream network section and create streams and outlets. You click on this option and it will do it. End of stream pre-processing. Okay, and here if you have and if you can and if you want, you can define your outlet and inlets. Now I want to define my point sources because I have some point sources and I will add it by table. You should have dbf file format. I will show you right now optional layers and point source dbf. You can see that all my point sources now is added to the map, and these point sources are like wells and these things. Inlets and point sources added to current set. Okay, and here it says it just makes a report, and its original table outlets is 129 and table outlets snapped 128 and duplicate ones were 67. Click OK, and now I want to just show you how to prepare this point source file. Here you can see that I have an Excel file for point sources, and you see that these are UTM-X, UTM-Y, UTM-X, and UTM-Y, and longitude and latitude, and that's the type of this point source. Now D is well, and there are other um, other letters for other forms of point sources that you can just go to the manual of SWAT and find them. Now you can see that I just have wells, so it's all D. Okay, then you should use softwares or online systems that are provided that convert the Excel file into DBF file formats or whatever else. But here you want DBF file. So you can use that in order to change this format to DBF. It's so easy. You can do it, but if you couldn't, make questions in the comment section. I will answer them. Okay? Okay, let's get back to our process. And then watershed outlets selection and definition. Now you should use this option in order to, you can see here, whole watershed outlet. My whole watershed outlet is this point. Now actually I don't know how you should understand that, but me myself, I um, I know this whole watershed outlet the by papers I have read, and by like physical visitation of this watershed. But use whatever information you have in order to understand where is your whole watershed outlet. Click on that and it says hold down the left mouse button and drag a box to select outlets. Okay, and that's here. One outlet selected and okay. Now there is a option like opened. It says delineate a watershed. Okay, click on that and it takes some moments. Watershed delineation is done. Okay. Here you can see another option is shown. Calculate subbasin parameters. With no doubt, click on that and it will do the things needed. Subbasin parameter calculation successfully done. Okay. And here it makes some geodatabase files and export it. Let it do the things needed. Okay, now you can click exit on or minimize it, no matter, but I usually exit. Here, if you want, you can have watershed reports, topographic reports, okay? And it says it provides a small report, and but actually, if you want the truth, it's not that usable. It doesn't give you very valuable information, but it's a report, okay? And then you should go through HRU analysis. Actually, it's the place your modeling actually starts. Click on land use, soils, and slope definition. Okay, land use grid. Here you want to inform your land use that you have already made or you have acquired by organizations or through the web or anything else. Now it's load your land use data set from disk. I will click on that and say okay. Now it asks, is the grid or the shapefile projected? It should be projected before continuing. I say yes, it's already projected. Okay, now I want to go through land use and 2000 and maximum likelihood and this map. Okay, here it says your land use data have been successfully loaded and clipped to the watershed boundary. It says overlap area is this much and percentage of overlap is 99.69. It says that overlap of less than 100% may result in some subbasins without any land use data overlap. And after that, it says this situation might result in some like mistakes and these things, but actually in my experience with this much like with this much less than 100%, I didn't have any problems, so I just click OK and continue. But you should know that if it's far less than 100%, then you should make your land use map again and make it near 100%. Okay, choose grid field, actually value, click OK. Lookup table. Now you should inform your lookup table, and that's user table, okay? And now you go through. Okay, and I don't remember if I have already told you how to make these lookup tables or not, but if just here I want to show you, these lookup tables are so easy to make and so easy to prepare. And I should go to, it's a text file, it should be text file, and it has two like columns. The first one is value, it should be on double quotations, and the next one is land use, it should be on double quotations again. And the first one is just numbers ordinally, and after that is the land use. This land use is selected from the database of SWAT model, and if you want to know where is your database, you should go to this PC, local disk C, and here you can see SWAT. Okay, arc SWAT, and in databases, these are your databases: SWAT 2012 and SWAT US Soils. These are all different databases that SWAT uses. And that's it. You go through your SWAT 2012 database, and then based on land uses used in your map, you should choose the like these codes that are written here. Okay, and that's your lookup table. Then click on reclassify. Land use reclassify completed. Click OK. And then go to the next section, soil data. Now you should add your soil grid or soil data. You should do it by load some data sets from disk. Okay, click on that. Click OK. Is the grid or shapefile projected? Yes, of course, it's projected. And let me find it here. Okay. That's it. And here you can see percentage of overlap is 100%. It's very good. Now you should choose grid field. Click value, okay. And then you want user soil, lookup table, and that's my lookup table. I don't know why I'm getting this error and I don't have any idea. Okay, let me check something and come back to the video. Okay, that was just I don't know why it occurred, but I just closed this section and again opened it and it's all right. I clicked on lookup table and chose this one and clicked select, and now this is shown here. I will click on reclassify, okay, and then go to slope. Now I use single slope, but if you know just how many percentage of your study area has which slope, you can use this option, but I use this option and my model is okay and I don't have any problem, so I just go through it and I click on reclassify. Okay, and then here you should create HRU feature class, and because I just closed it, I should again define my land use because it doesn't appear the overlay here. I wish it works. I don't know. You know, ArcSWAT is a lot based on trial and error, so just keep going on. I can tell you keep going on and don't stop. Okay, lookup table here is okay, yeah, this option is now opened and I check this option and I click on overlay. Okay, when it's finished, it says finish land use soils slope definition and click OK. And then you should go to HRU definition. Click on that and this window appears. Now, HRU definition, dominant land use soils, dominant HRU, target number of HRUs, multiple HRUs. Put it on its default. Threshold percentage, yeah, percentage, and land use percentage over subbasin area, soil class percentage over land use area, and slope class percentage over soil area. Now, based on articles that I have read and based on all the researches I have during this period of time, I understood that if I put it on 10, 5, 5, or 20, 10, 10, it will be alright. So I will put on 10, 5, 5. Then go to the next segment, land use refinement. And it's optional and I don't want to make any refinements, so I will go through elevation bands. Now I will check this one, generate elevation bands, and then click on create attributes. It will take some moments, so I will pause the video and come back to you. Okay, now as you can see here, it shows a message set completed HRU definition. Click OK and head to HRU analysis reports. Now you can see it has two options, final HRU distribution. Click OK and now you can get a report of your HRU distributions. So you can see that you have classes for land use, agricultural land generic, agricultural land row crops, range grasses, orchard, and residential medium density. Then you can go to soils. You can see that you have different classes for soil, and then it says it has reports for each subbasin. Subbasin number 1, it has this much area and other information provided here, the soil characteristics for subbasin number 1 and slope characteristics and actually HRUs that are included in subbasin number 1. Subbasin number 2 and to the end, that is subbasin number 31. Actually, I have 31 subbasins out here. So I will close it and cancel it and go to write input tables. Now you want to define your weather stations. Click on that and that's the window appeared here. First, you want to define weather generator data. What is weather generator data? I will make another video explaining what is WGN and what is used for and how should you make that file and actually how should you inform it to your database. Now let me skip um, this section and here you can use WGN user. I will choose it and go to rainfall data. Now here you can either choose rain gauge and choose simulation. In simulation mode, ArcSWAT uses its own simulation model in order to simulate all your weather data. Now you can choose to just provide, for example, rainfall data and make SWAT simulate all other data, or just simulate all data, or just inform observation data for all climate parameters. Now, because I haven't taught you how to make the observation weather data for SWAT and how to prepare them, I just skip this level and I choose simulation, and I will make another video um, teaching you how to make files needed for this weather data definition section. Okay, put all those other sections on simulation and click OK. Processing complete. Okay, we just want to run SWAT model, and we don't want to informat your weather data because I haven't taught you. Okay, then you go to write SWAT input tables. Okay, you can see all of them are in red and it says incomplete. So click on select all and create tables. Yes. You can see it reads and it writes all your information tables or your input tables, and actually your model is being built right now. It's just putting together all your input data into one meaningful model. Done building selected tables. Okay, and here here you can choose point source discharges, and you can just inform your table that it concludes these discharges of wells and all point sources you inform to your model. But right now we don't have time and we just want to make a very initial SWOT model, so I will skip this section and I will go right to watershed data and generate data. We go here in order to choose another method for PET calculations. I will choose Hargreaves and save edits. Okay, and every edits you make in your SWOT model, you should go to rewrite SWOT input files. And what was it? It was for basing section, so that BSN, write files and click OK. And now you're all done. You go to run SWOT. Okay, starting date is 19/2 and ending date is 2100. And so I don't want this long. I will choose it from 1990 to 2020. It will be 31 years. Here, don't change this section and go to 64-bit release. If your system is 64-bit, choose this one. If it is 32-bit, choose this one. Then printout settings, I will always put on monthly, and I have a good reason for doing that because after this process and after this level here, you want to calibrate your model. Now my data for flow out, the data that we usually use in order to calibrate our model, is monthly, so I will choose print out settings for monthly to calibrate it on right basis. So this one, it has number of years to skip. Here it is the warm-up section. Now your model uses the first number of years at first of the starting period, the starting point as warm-up. In this warm-up period, your model runs and actually produces outputs, but it doesn't show you, and it just uses that output in order to warm up itself. I will choose it for 2 years as a warm-up, and then you choose setup SWAT run, finished setup, okay, and go to run SWAT. Now your model is running, executing year number 1, and it goes to number 31. Okay, so I run successful, thanks God, and go to cancel it. Now you want to read SWAT output. Here you can choose output reach, output subbasin, output HRU, output okay, that's it, and import files to database. You import these outputs to your SWAT database. Okay, it's done, and then you can run SWAT check. Now SWAT check is the initial model that you can use it in order to read your SWAT outputs and read and see what is calculated by SWAT model. It's very useful, and it gives you very good insights, and it just tells you some bugs that you have on your model and the places you want to make the refinements and make improvements, and it's a very good model. In previous versions, like in SWAT 2009, it was separated model, but now in 2012 model, it has a built-in model. Um, Actually, it's in your SWAT model. Okay, go to section hydrology, and it says that how many um, um, how much water is gained by precipitation, how much is lost by evaporation and transpiration, and what is infiltration and or plant uptake or soil moisture redistribution, how many percolation to shallow aquifer has made, how many re-evaporation from shallow aquifer has just occurred, and then how many recharge to deep aquifer you have in your model, how many return flow do you have, how many surface runoff do you have, and all these valuable information. Now you can get some messages and warnings. This is the section I said it's very valuable for you. It says surface runoff ratio may be high. It is actually, it's yes. Groundwater ratio may be low, and then somewhere here it says you're using simulated precipitation data. If you intend to calibrate, you should use measured precipitation data. Actually, if I want to tell you something, I should tell that many of these warnings and error and this like very weird numbers are because you're using simulated data. You should use observed data in order to have a good model with good accuracy, and in order to prepare it for calibration actually. Okay, that's it for today's video. In the next video, we will see how to prepare our observation weather data, how to make WGN table and how to inform it to your SWAT database. I will thank you so much if you give this video a thumb up, and if you subscribe to AgriMedSoft channel and see other videos and see this SWAT playlist updated. Thank you so much, and I will see you in the next video. Bye.